together, we were talking about points and circles, and I started talking about lines and circles. And if you recall, one of the things that we had discussed is what happens when a line touches a circle in one place only. All right, and then when that happens, when a line touches a circle in one place only, what do we call the line?
It's a tangent.
It's a tangent, absolutely. It's called a tangent. Oh, why am I doing this? Sorry, it's scooted over to the side. Hang on a second. Absolutely. So it's called a tangent. And if we were to calculate the coordinates at the point of tangent C, all right, and if the line was a tangent, there would only be one pair of coordinates. If the line was a secant and it went straight through the circle, then there would be two pairs of coordinates. Okay, so when lines are tangents, there's only one pair of coordinates when we calculate the point of intersection. But before we get started on determining the equation of a tangent, which is really important, I just want to link back to some concepts that you would have actually learned in Euclidean geometry in grade 11 that are super important for our understanding now. Okay, so the first thing is that the tangent, or a tangent, a tangent to a circle is always perpendicular to the radius at the point of contact. Okay, so what I've got here in orange or red is my tangent. My radius I've drawn in green, and I've shown you that my radius is always perpendicular to my tangent. So how I would write that is radius perpendicular to tangent. That was the reason from grade 11. Or if you needed to make a statement before you did that, let's just rather start there, is I could say something to the effect of angle CAB equals 90. And then my reason for that would be because the radius is perpendicular to the tangent. Okay, so that's one important point. Another thing that's going to be important for us here is what happens with gradient. Okay, so in other words, if you have the gradient of your tangent and you multiply that by the gradient of your radius, you are always going to end up getting -1. Okay, so that's super important. But sometimes we will have to use the gradient of the tangent to get the gradient of the radius, or sometimes we'll have to use the gradient of the radius to get the gradient of the tangent. So that's another really important point to note at this stage. The other thing that I did in this triangle is I drew a dotted line from C to B, and that is because often in matric, well, not often, but sometimes it comes up that we need to join 2 points, and we don't normally do constructions, but we are allowed to construct a line like from C to B to create a right angle triangle. And because it's a right angle triangle, the other thing that we need to bear in mind is that we could also use the theorem of Pythagoras. I hear you all bellow. Yes, absolutely, quite right. Okay, so in which case we would say that CA squared plus AB squared is equal to CB squared. Okay, so don't forget about good old Pythagoras. Now, I see there was a hand that went up. Was it you and me, Claire? Or am I imagining things? Okay, maybe I'm imagining. Sorry, Emilia, I thought I saw you put your hand up, but okay, all right. Is everybody fine with that? Cool, happy, yes, we can carry on. Okay, and then the other concept with regards to tangents and circles from Euclidean geometry that's really important is that 2 tangents drawn from the same external point are equal in length. Okay, so in this particular case, I have drawn, again, the tangents in orange, and I have drawn the radii in green. So what we would be able to say in this case over here is that, firstly, BA is equal to BT, tangents from the same point. Okay. Again, the radius is perpendicular to the tangent. Okay, so that means that CAB equals 90 And it means that CTB equals 90. Radius perpendicular to tangent. But something else emerges. In fact, another two things emerge from this diagram. Can anybody tell me what kind of quadrilateral BACT is?
It's a kite.
It's a kite, absolutely. And the reason that we can say that it's a kite, Morongoa, why is it a kite?
I'm not sure about the reason, but I see kite.
There, you know, you're quite right. You're absolutely right. Okay, so agreed, CT equals CA, yes? And AB equals TB. Okay, CA equals CT because they are radii. AB equals TB because they are tangents from the same point. So the reason that it is a kite is because you have two pairs of adjacent sides that are equal to one another. Okay, so whoopsie, I was writing in purple. I suppose we can write in orange, it doesn't matter. So two pairs of adjacent sides are equal. And I hate to be the bearer of bad news, but the properties of quadrilaterals are important in matric. You are sometimes asked why something is a rhombus or why something is a kite, or they'll give you a kite or a rhombus or a parallelogram, and they'll expect you to know and be able to use those properties in your solutions in analytical geometry and in Euclidean geometry. So yeah, if you haven't brushed up on those, then make sure that you do incorporate that into your studying. There's one more thing that I can say about BACT before I move on. All right, and I'm going to let you guys look at BACT, and I want you to tell me, you've told me that it's a kite, which is cool, but there's something else that it is. Can anybody tell me what else BACT is? And I'll give you a hint. It's not a parallelogram. It's not a rhombus. It's not a square. Hey, Buhle. Nice. Well done. Yes, Marco Sandile. 100%. It is a cyclic quad. Why is it a cyclic quad? Anyone, can you remember the three reasons how we would prove that a quad is cyclic?
Can I try it?
Go for it, Morongoa.
Two opposite sides of a cyclic quad are equal.
Almost. It's not two opposite sides. So if the two opposite angles add up to 180 degrees.
Angles. I want to say angles.
Yeah, that's fine. Okay, so because CAB is 90 and CTB is 90, that's what makes BACT cyclic. So actually, if we needed to set it out in the correct way, we would have had to state that. So we would have had to state what I've written here in my second line. Let me just put it over here. So in other words, CAB equals 90 and CTB equals 90. And the reason for that is because the radius is perpendicular to the tangent. Thus, when we add CAB to CTB, we get 180 degrees. So that means that BACT is cyclic. And here we have to use, do you remember this grade 12's converse? Opposite angles of a cyclic quad are supplementary. Does that ring a bell? Yes, no? How are you feeling? Yes. Oh, good. Oh, good. I'm glad it rings up. So can you see, this is one of the reasons why I wanted to start in this place, because often in maths, we learn things in isolation, like we learn about trig and we learn about Euclidean geometry, and we learn about analytical geometry, and we never see the interconnectedness. And that's really what we want for you as teachers, is to understand how everything is actually connected together. Also, we like to ask you questions Michelle, I'm going to answer that question now. We also like to ask you questions. They're level 3 questions, that we refer to them as complex questions, where we link together different parts of math. So if I link together a concept from Euclidean geometry with analytical geometry, that's a level 3 kind of question. It's a complex question. So it's very important, if you're going to try and access those questions in a paper, that you understand the interconnectedness of things. All right, so Michelle, your question was, let me just pull it up again. Ma'am, do we have to know the converse 2 in grade 12? Oh yes. Oh yes, you do. So Michelle, I don't know if you were around earlier this year. I did a course on Euclidean geometry, and one of the things that we discussed was the grade 11 Euclidean geometry. So yes, you would definitely be asked to prove that a quad is cyclic in paper 2. Probably not in the analytical geometry section, but in the Euclidean geometry section of the paper, definitely. Okay, it is something that does get asked. So yes, these converses are important. Okay, so that being said, let's move on. I want to talk now about determining the equation to the tangent of a circle. And this is sort of the simplest example that I could think of. All right, so we are given a circle, the one in blue, and we are asked to determine the equation of the tangent to the circle, and the tangent is going to be the orange line, okay? Before I get started, a couple of questions. First of all, what are the coordinates at C matrix? Can someone tell me what are the coordinates at C?
+3 and +1.
+3 and +1, absolutely. Okay, good job. So you read that, Ryle, from the equation. Okay, 100%, that's really good, well done. Okay, so, and we can see the point C lies in the first quadrant, so that makes sense that it would be +3 and +1, so that's awesome. Okay, next thing that we need to take cognizance of, they want us to determine the equation of the tangent to the circle. So all lines that are tangents take the form of what matrix? What is the general form of a tangent, or any straight line for that matter, any straight diagonal line? They all take the same form?
Y is equals to mx plus g.
Beautiful. Okay, that was really great. I didn't pick up who was talking, but whoever you are, that was 100% perfect. Y equals mx plus c. Cassandra, do you have a question, or did you want to say something? Oh, you wanted to answer. Okay, the next one's all yours. Okay, Cassandra. All right, so y equals mx plus c. So matrix, when they tell you that you have to find the equation of a tangent, what they are telling you, what the instruction is you need to work out the gradient. You need to work out the value of m, and you need to work out the value of c as well. Okay, so that is your job when it says determine the equation of a tangent. Okay, so now first things first, if we want to work out the gradient of the tangent, all right, we can draw a line from the center of the circle to the tangent, and we know that the purple line, the radius, is going to be perpendicular to the orange one. What can we use to link the information that we've got about the radius, or the gradient of the radius, to the gradient of the tangent? Can anyone tell me? How am I going to go from the information that I've got? So in other words, the coordinates at the center and the coordinates at S. How am I going to link that to the gradient of the tangent? No idea?
They have, wait, they're perpendicular, so the gradient is -1.
Absolutely. So the product of the gradients is -1. Quite right. Okay, so in other words, the gradient of the radius times the gradient of the tangent is equal to -1. So if I work out the gradient of the radius, I can calculate the gradient of the tangent from that. How do I calculate the gradient of the radius? Gradient formula, all right? So that is going to be change in y. So 5 minus -1, change in y, over change in x is going to be 6 minus 3. And when I multiply that value by the gradient of the tangent, I'm going to get -1. All right, so now here on the left-hand side, I've got 5 plus 1, which gives me 6, and 6 divided by 3 will leave me with 2. Is everybody happy with that? And again, if I go back and I look at my picture, my answer seems reasonable because line CS slopes up to the right-hand side. It has a positive gradient. So I'm feeling pretty good about what it is that I've done here. Okay, and now I'm going to divide both sides of my equation by 2, and that means that the gradient of the tangent is going to be equal to -1 over 2. All right, very nice. Good, guys. That's lovely. Well done. Okay, so that is your first job, okay, is to work out the gradient of the tangent from the coordinates at the center and the coordinates at the point of tangency. You've got to calculate the gradient of the radius and then say the gradient of the radius times the gradient of the tangent. Well, the gradients multiplied together gives you -1. Okay. Cool. Now that we know what the gradient is, we can come along and we can sub that into y equals mx plus c. Now it's our job to work out the value of c, aka the y-intercept of the line, right? So now we need a point that the line goes through. So what point can we use? Can we use c? No, definitely not. Okay, we have to use S, quite right, Cassandra. Okay, because the tangent only goes through S. The tangent obviously does not go through C. Did I make a mistake, Neo? Isn't Y? Where did I make a mistake, Neo? I'm not sure.
I meant by y, because in the equation was y minus 1, not y plus 1.
I think point C is +3 and +1.
Yes.
Oh, hang on a sec. Oh, okay. Sorry, I wrote -1 over here, which was so silly of me. Okay, hang on a moment. Thank you. Thanks for that. Okay, hang on. We spoke about that in the beginning. All right, so this was, hang on. This was 3 and that was 1. We discussed that. So here we should be saying the difference in y, so that would be 5 minus +1. So that would be 5 minus 1, okay, which would leave us with 4. And 4 over 2 would leave us with 2. Okay, all right. So it worked out in the end, but yes, I did make a mistake in the numerator there. My apologies, Neo, and thank you for pointing that out to me. Okay, I think we're all good to go now. So in order to work out the value of C, we've got a sub in point S, 6 and 5. So that means that when y is equal to 5, x is equal to 6. So that means that we have got half of 6, that would leave us with -3. And now I need to add 3 to both sides. So that means that C would be equal to 8 in this case. All right, so now the equation of the tangent, it is the line y equals -1 over 2x plus 8. Okay. How does that feel, guys? Emojis? Yes, no?
Ma'am, isn't 6
Am I
minus
just
3?
being stupid here? Sorry. It's been a long day. I beg your pardon. 6 minus 3 is 3, isn't it? Hang on. Courtney, sorry, I'm being an idiot here. 5 minus 1 is 4, and 6 minus 3 is 3, isn't it? Okay, so that means that when we now have to multiply it by the gradient of the tangent to get -1, this would end up being -3/4. Sorry, I used the wrong number. Sorry, guys. Let me just fix this up for you. Right. The method is correct. It's just the numbers.
You're just
that were
keeping
wrong.
everyone.
Sorry, guys.
You're keeping
Okay.
everyone on their toes.
Yeah, I told them at school I did that on purpose so that to see whether you were all paying attention or not. I don't know if I'm going to get away with that here. Okay, all right, so the gradient of the tangent is -3/4. That makes sense to us because it does slope down to the right-hand side. And now we would need to go and sub the point in. So remember, x was 6 and y was 5. So 5 would be equal to -3/4 times 6 plus c. So now we can work out the value of c. So that gives us -18/4. So that means that c would be equal to 5 plus 18/4. And that would be 19/2. There we go, that's better. Okay, so that means the equation of this tangent, it is the line y equals -3/4x plus 19/2. My apologies. Does that make sense now? Were we all good, Matrix? All right, you ready to try one? Okay, cool. All right, so I'm going to move. Yes.
Where did we get it? Where did we get the -18/4?
Okay, so you said -3/4 times 6. Can you see there?
Yes,
So we were multiplying the gradient by the x coordinate.
okay.
Okay.
Oh. So maybe if I had to say, if I get 9/2, -9/2, is it still correct?
You mean if you write -18/4 is -9/2 is perfect.
Yes, ma'am. Okay.
Same
Thank you
thing.
very much.
Absolutely. Yeah, your calculator will simplify it for you. Yeah. Okay, no problem at all. Okay.
How you got -1?
Say again, Ryle, please.
Ma'am, I have one question. How you got -1?
You mean up here at the top, this one? Here, how I got -1. Okay, so that's a rule. That's a rule. So that is something that people that have studied maths for many years have discovered to be true. So when lines are perpendicular to one another, the product of their gradients always gives us -1.
Okay.
Okay.
Thank you, ma'am.
All right. So that's a property of perpendicular lines that we are just expected to know and to be able to use. Okay. All right. Cool.
Yes,
okay. So now, cool. All right. So now, guys, here is one for you to try. Similar, not exactly the same, but similar. Okay. So I want you to find the equation to the tangent. Sorry, the equation of the tangent to the circle. The circle is given. And the point of tangency is given, and the center of the circle is given. Okay, give that a try. And you may need y equals mx plus c. I'm also just going to write the equation of a circle here for you. Not that you... There you go. All right, so Courtney and I are going to be quiet for 5 minutes. We'll let you work on that, and then we'll talk about our answers. When you're done, you can just pop the word done or a smiley face or a thumbs up into the chat, please. Cool, Cassandra, well done. Well done, Buhle. Well done, Lorato. Nice Moronkoa. Good, Roru-san. Cool, Mihle. We'll just wait 1 more minute and then we'll talk about our answers. Cool, Mako. Well done, Tato. And Neo. All right, cool. So, who was first to answer? Cassandra, it was you. Okay, so that means that you've got top billing, Cassandra. You can tell us what your answer was. What did you get as your equation of your tangent?
Ma'am, I got -1/3x plus 10/3.
Okay. And who agrees with Cassandra? Yeah, me too, Kanyasile. Okay, I agree. I do. We concur. We do, we do, we do. All right. Good job. Well done. Okay. Yeah, nice one, guys. Anybody get a different answer and doesn't know where they went wrong? Or was that really easy? I think that was easy enough. Cool. Well done, Cassandra. That's excellent. Okay, nice. Okay, in that case, let's move on if there's no questions. Yeah, it was easy. Good, can you see there? I'm glad that it was easy. Okay, let's do another one. Okay, so now in the diagram alongside, we have got M, the center of the circle, the line through P, the straight line through P, which is a tangent to the circle. And it has the equation y equals half x plus 7, all right? We need to calculate the coordinates of P. Okay, so we've spoken a little bit about how to find the coordinates at a point of intersection. And in our previous lessons, we've spoken about how to use the equation of a circle together with the equation of a line to find the coordinates at the point of intersection. Do you think that that's what we're going to do here? What do you guys, how do you think we're going to solve this? Okay, maybe I must change my question. Do we have enough information to get the equation of the circle? Is there enough information for us to get the equation of the circle? Okay, so Kanyisile, you say yes. All right, so Kanyisile, if I was to put the information together to get the equation of the circle, what would you tell me to write? What should I assemble? What do you think I should put down on the paper?
Ma'am,
Mm-hmm.
I have a question.
Sure.
Since P is a tangent to the circle, would we still say that P and M are perpendicular to each other? Can
Absolutely.
we assume that? Okay.
Absolutely. Okay, so I'm drawing a very, very terrible radius here, but quite right. So PM is the radius, and it will always be perpendicular to the tangent, 100%. So do you just want to stick with your idea about getting the equation of the circle? Do you think that that's what we should do in this case? You're the only person that's responded to me. What about everybody else? What do you guys think? Do you think we should go with the equation of the circle? Do we have enough information? And if so, how would I put it together? Okay, so Injabulo agrees with Kanyisile. So Injabulo, what should I write if I wanted the equation of the circle? And in what form could I write it? Remember, I can write the equation of the circle in two ways. Either I can write it in a standard form, okay, which is going to be difficult for me in this situation, or I can write it in center radius form. So because I've got the coordinates at the center, I could potentially write it in center radius form. Okay, let's just have a look at somebody else. What someone else said? No, we don't have another corner to find the radius. So exactly, Moronkoa. Exactly. Okay, that's exactly the whole point. All right. So whilst we could be misled to thinking that we should work out the equation of the circle, so in other words, x plus 2 squared plus y minus 1 squared. The problem with this, as Moronkoa has correctly pointed out, is that we do not have another point on the circle. That means we cannot solve for r squared. So that means for us, matrix, we have got our x that's unknown, our y that's unknown, and our r squared is unknown. So the equation of the circle,
how to solve it.
Go for it. Go for it. Liam, tell me what to do.
So I think we can use the MP, well, the graph of y equals 1/2, well, the gradient of the graph 1/2 x plus 1, and then times the gradient of MP would equal -1.
Okay,
Then,
so a half, let me just write down what you're saying because you're on the right track here, times the gradient of MP, PM equals -1. Good, keep going.
Then, once we have the gradient, we sub in the point M to find the equation of graph MP.
Okay, lovely. I love the way that you're thinking. Okay, so now we're going to work out the equation of the radius. Is basically what Liam is saying to us. So we're going to use y equals mx plus c because it is a straight line. We know that the gradient is -2. We also know that at m, which is a point that the line goes through, y is equal to 1. The gradient is -2. X is equal to -2 plus c. So this means we've got +4 plus c and 1 over here. So c will be equal to -3 if I'm not talking any nonsense. All right, lovely. Now, why is Liam working out the equation of the radius? What's he going to do with this information? Yes.
I think we're going to equate the equation of the radius and the equation of the tangent together in order to solve for the point.
Good, Kanyisile, that's brilliant. That's brilliant. So the reason why I included this example, I'm really pleased, Matrix, that's lovely. The reason I included this example is because remember, if you've got a radius and a circle and a tangent, that point of tangency, in this case it's called P, is not just the point of intersection between the circle and the tangent. It is also the point of intersection between the radius and the tangent as well. Okay, so quite right, in this case, we are going to take the equation that we have just made. So in other words, we are working with the line y equals minus 2x minus 3. That's the equation of our radius, negative gradient, negative y-intercept. And now we are going to equate that to the equation of the tangent. So 1/2 x plus 7 is equal to negative 2x minus 3. All right, there we go. And now we need to solve for the x coordinate at the point of tangency. So it's up to you at this point. Either you can collect the x terms together, or you can multiply through by 2 and then collect the x terms together, whatever floats your boat. I always like to get rid of fractions, so I'm going to multiply every term by 2. That's going to give us x plus 14 equals minus 4x minus 6. And then we want x plus 4x equals minus 6 minus 14. And that means that 5x is equal to negative 20, which means that x is equal to negative 4. So now let's go back and have a look which quadrant we are working in. Okay, so we're in quadrant 2. So we were expecting a negative answer for x. Okay, so that does seem likely. And now we need to go back and sub in order to get y minus 2 times negative 4 minus 3. So that gives us 8 minus 3, which is 5. So thus we are saying that the coordinates at P will be negative 4 and positive 5. Okay. All right. So Cassandra, you say you don't understand. No problem. Tell me what you don't understand and we can talk about it. Where did I lose you, Cassandra? From the first part. Okay. So in the beginning, we were talking about how we were going to solve for the coordinates at P. All right. And in the beginning, because the radius is not drawn, we are misled into thinking that the only way to solve for P is to solve for the equation of the circle and then equate it to the straight line, which is what we were doing in our previous lesson. Do you remember? But the problem with this particular question is that we do not have enough information to formulate the equation of the circle, because not only is x and y missing, but the length of the radius is also missing. We don't have another point on the circle to solve for r squared. So what that means, Cassandra, is that we cannot use the equation of the circle to answer this question. So if we need to solve for a point, if we need to solve simultaneously, the only way that we're going to be able to do it is by using the radius, which I'm now drawing in bright pink, okay, and the tangent, which is in orange, okay, because point P is a point of intersection between the radius and the tangent. Okay, the circle goes through there as well, but P is a point of intersection between the radius and the tangent. So if I can work out the equation of the radius and equate it to the equation of the tangent, I can solve for x and then for y. Does that make sense? Sure? Okay, so that's what we were doing, Cassandra. We were first working out the gradient of the radius. That's this bit when Liam was talking. That's the gradient of the radius. All right, then the radius goes through the center of the circle, which is why I subbed in the points -2 and 1. And then what I got over here, this was the equation representing the radius line PM. The other one was the tangent. This is the one that has been given to me. Let's not use green since I've written in green. Okay, this one over here is the equation of the tangent, and that was given to me. Okay, so I first had to make the equation of the radius. Then I had to equate it to the tangent, and then I had to solve for x and then for y. Okay, Cassandra? Are we feeling good, Matrix? Are there any other questions? Can I move on? Pleasure. All right, so now some work for you. Okay, so here you go. This question is for you guys. I've made it nice and big. So there are 2 questions that you need to answer here, A and then B. Okay, so again, Courtney and I are going to be quiet for a little while. And when you are done, you can say done in the chat, or if you get stuck, please do not hesitate to call on me. Okay, all right, off you go. And again, what I'll do is just write the equation of the straight line and the circle. Okay. Cool, Cassandra, well done. I'll just see where everybody else is. How you doing, guys? Is it a bit challenging, Michelle? That's okay. This is meant to be just, it's actually a combination of everything that we've done. So yeah, I'm asking you kind of put it all together. Cool, Neo. Cool, Elizabeth. Nice, Liam. Good Morongoa. Good Kulani. Cool, Mako. Nice, Mihle. Well done, Buhle. I'm going to wait 1 more minute and then I'm going to go through the answers. And that's because Courtney also just needs an opportunity to be able to talk to you guys this evening just for a few minutes. So I just want to wrap this up before she talks to you. Can you see, Lee, you done too? All right, cool. All right, so let's talk about how we would have found the solution to these two problems. The first thing that they asked us to do was to determine the equation of the radius PQ. All right, so that we can see is not too difficult. All right, well, hopefully it wasn't too difficult for you. PQ is the radius, and the radius is always perpendicular to the tangent. Because we don't know the coordinates at Q, it means that we have to use the equation of the tangent that's given to us. But as Kanyasile and I were discussing, you have to get it into standard form first, which means that it should have been minus 2x plus 11. Did you get that, Kanyasile? Did you get the negative 2?
Yes, ma'am.
Good. All right. And then our job is to say, well, the gradient of PQ times, whoopsie, that's not times, times negative 2 will give us negative 1. So the gradient of the radius times the gradient of the tangent is negative 1, which means that the gradient of the tangent, sorry, of the radius, beg your pardon, is going to be 1 over 2, like so. Okay, now we know that the radius goes to point P, so we can sub in y equals mx plus c. So y is negative 1 when x is equal to 1. So that means that c was going to be equal to, I got negative 3 over 2. So therefore, the equation of the radius PQ, it is the line y equals 1/2 x minus 3 over 2. All right, do you guys agree? Did you get the same answer? Oh, that's awesome. Look at all those lovely thumbs ups. Well done. Well done. That's great. Brilliant, guys. Awesome. Really nice. Now, okay, so let's whip through this bit because I know Courtney wants to talk to you. Okay, now for the equation of the circle, all right? Remember, like with the previous problem, we couldn't work out the equation of the circle because there was a key piece of information that was missing. What was that key piece of information? It was a?
It was a P in the last question.
Okay, so the reason that we couldn't work with the equation of the circle in this question is because the coordinates of P were missing. Okay, we didn't have enough information. Whereas now, do we have enough information to be able to work out the coordinates at Q?
No, ma'am.
Don't we?
We don't have the coordinates of Q.
Okay, so is there another way that we could work out the equation of the circle?
First, by equating the equations and then getting our Q, and then using our Q into our radius formula in order to get the equation of the circle through Q with center P.
Okay, so you don't need the gradient of a line to get the equation of the circle, all right? But I quite agree with you. Well, this is what I did. Okay, let me just explain to you what I did. I then equated minus 2x plus 11 with what I have just calculated. So in other words, half x minus 3 over 2. This is to get the coordinates at Q, right? So now the coordinates at Q, minus 1 over 2x is equal to negative 3 over 2 minus 11. And I'm just going to times through by 2 because it just makes life so much easier. So minus x is equal to minus 3 minus 22. So that gives us negative 5x is equal to negative 25, which means that x is equal to 5. So that is the x coordinate here. It's 5. The corresponding y coordinate, y equals negative 2 times 5 plus 11 will be equal to 1. So this over here is 1. And the reason that I wanted the coordinates at Q is so that I can use that point to sub into the equation of the circle. All right, because now I know what the coordinates at the center of the circle are, 1 and minus 1. So that means I can write x minus 1 squared plus y plus 1 squared equals r squared. And then I can use the coordinates at Q, 5 and 1, because this is a point that lies on the circle, and I can sub that in. So here I'm going to sub in the 5. Here I'm going to sub in the 1. Ooh, that's a 1, not an r. And that means that r squared is going to be 16 plus 4, which is 20. Hang on, let me just check this. Okay, there we go. Sorry, I was just having a look. Yes, I quite agree, 20, which then means that the equation of the circle, it's going to be the line x minus 1 squared plus y plus 1 squared equals 20. You got that same answer as me. Cool, Kanyasile and Morongo and Cassandra, good. And Rorasang, nice, got it. Nice, Mako, good, Neo, well done, Tato. Nice, Liam. Good, Emihle. Good stuff.
Teacher Lee.
Yes, sorry.
No. Bushle asked a while ago if you could use the distance formula.
Yes, absolutely. So in other words, Bushle, if you wanted to work out the distance of PQ, absolutely you could do that. It would be an alternative to you subbing into this over here. Okay, so instead of me subbing in the point over here and solving for r squared, you could then use distance formula to calculate the length of PQ and then square it 100%. Nothing wrong with that. Okay, how do you feel, guys? Cool. Cool, Kanyasile. I'm glad you feel happy. Good, very good. Lovely. Good, Kulani. Good, Cassandra. Thank you, Thelma. Cool, Emihle. Nice, Mako. Good, Liam. Cool, little Malane. Good, Ayavua. All right, well, it seems as though I've taken up all Courtney's time here. She just wanted to talk to you very quickly. Cool, Buhle. Well done, guys, and I shall see you again next Tuesday. I hope you have a lovely week. Oh, actually, I won't. I'll see you on Saturday because we've got the second part of our exam prep course to do. Okay, so yeah, for those of you that are going to be joining us, I'll see you then. Otherwise, have a good weekend and I'll see you next week.